Hey everybody, this is Alex Merced from alexmercedco.com, and welcome to our second video in our Intro to SQL in 2021. Now again, you could be doing this from a terminal or using a REPL as directed in the first video in our setup video. But either way, we're going to be generally using the shell. So if you are on REPL, make sure you're on the shell tab here. And if you have installed it, just make sure you do have it installed. So type in SQLite 3 -- version. And that'll tell you which version you have installed. I'll do the same thing here, SQLite 3 version, and it'll tell you which version you have installed. So what I'm going to do is I'm going to make this one, I'm going to expand this, so that way, because we're not going to really need this file screen. And then we'll see if I can make the font bigger, font size. Let's make it huge. Oh, that only made it there. Okay, so let's see if we can make it bigger here. Previous note. How about if I do this? Yes, that works. Okay, it's just so that way you can read that better. Can I hide this? I don't think I can. That's fine. Okay, so essentially what's going to happen is that when you do the SQLite command, so SQLite 3, that's the command, it'll open up the file that you give afterwards. So whatever file name you give afterwards, it's going to create a database. It's either going to open up the database if that file exists in the folder you're open to. So again, always take a look at what folder you're currently in. Okay. Or it will create the file if the file doesn't already exist. Okay. So what I'm going to do is I'm going to create a file. We'll just call this first.db. It's our first database. Okay. So when I hit that, and again, this thing right here, so this thing right before my command is always referred to as my prompt. Okay, so the prompt can change as you're in different programs. So always keep in mind, like, this is sort of the default prompt, meaning I'm not in any particular program. So see how, like, it just says the name of the folder I'm in and has a $sign, so just keep that in mind. Now if I hit SQLite 3 first DB, notice my prompt has changed. It says SQLite, because now I'm inside the SQLite software. It's like I opened the program. And if I'm ever wondering what the commands are, they're always going to start with like a dot. So like .help will list all the different commands that are available to me to kind of work with the software. If you're ever curious, really the only important one right now is going to be .quit. Okay, if you ever need to get out of here, I just hit .quit, and now I'm back and see I have my normal prompt again. Okay, which means I'm no longer in SQLite 3. I am in back in my normal terminal. So now if I want to clean this all up, I just hit clear. And that's going to clear everything out. And now we can do SQLite 3 first DB. Okay. Now, what we want to do first is actually create a table, because the way a database works is that a database is just like think of it as just like a hard drive, right? Or even just think of it as like a folder on your computer. So you have a folder. When you create the folder, you may have a folder, but it is empty. Okay, and you may have different, and then let's say you're using Excel, and you may have different spreadsheets that contain different data. Think of each Excel file as a table. So the folder is like your database that can hold many different Excel files, okay, many different spreadsheets, and then each spreadsheet is called a table, which can hold data, typically organized as columns and rows. Okay, but really it's not, it's all really being held in this one SQLite file that will be created in a second. So let's create a table. So a table, again, think of it as like one Excel spreadsheet. So I'm going to say create table. Notice I'm doing it all uppercases. That is not required. It's not required that I type every little letter in uppercase. But generally what you want to do is separate what is SQL from like your like output. So create table, that's an SQL command. So I type it in all caps. So that way, you know, when I look back at this query, it's clear like those are SQL keywords. And then when I give the name of the table, so we'll say my first table, that's all lowercase, because that's clear, like that's just a name that I'm giving. Okay, so that way it's always clear what is SQL, what are the things that I kind of establish. So I'm going to create my first table. Now whenever you create a table, SQL mainly handles structured data. SQL databases are structured, meaning they have to know sort of what kind of data they're going to hold up front. So even though we're not putting any data in this yet, we're creating a file and a spreadsheet that will hold data for us, we need to describe what that spreadsheet is going to look like. Okay, so meaning what are the different columns. Okay, so generally you're going to want to have an ID field, so that way everything has a unique ID. Okay, so in this parentheses, what I'm doing, I'm describing the schema or description of the table. So I'm going to say, hey, there's an ID field. Okay, and the ID field, I have to describe what kind of data is going to be inside this ID field. So I'm going to say serial, which just means a sequential number. So the first item will be 1, the second item will be 2, the third item will be 3. And I'm going to designate this as the primary key, which just means that this is unique. This is like the unique identifier. In the same way that I have like a social security number that is sort of like unique to me, that's my primary key, the thing that is unique and clearly identifies that I am who I say I am, the ID is going to be the primary key for the data in this table. Okay, so then I'll put a comma saying, okay, that's my first field. The second field will be called name, and it'll just be a sequence of letters. And one letter is called a character, so there's a type called varchar, which stands for various characters. So I'm saying, hey, this next field, it's going to be like words. It's going to be like, Steve, John, whatnot. So this field is going to be a varchar, and the limit of characters we'll say is 30. So no more, so the name cannot be longer than 30 characters. Then I'll close the parentheses with all my different fields. Okay. And then I'm going to end the command with a semicolon. So every SQL command has to end with a semicolon. Okay, now if I forget the semicolon, watch what happens. So take a look at my prompt. So here's my SQLite prompt. Now if I forget the semicolon, see, notice it realizes that my command is not finished yet. So I get this, meaning, hey, you're continuing the command that you had started on the previous line. Because it's like, hey, I'm expecting a command to end with a semicolon, or to look like something like this with a dot in front of it. So in this case, I got to put a semicolon because that's what it's waiting for. And now it's going to run the command. And notice the minute I created that table, a file got created over here, because basically the actual file doesn't get written to your computer till you actually create a table and whatnot. So that way there's actually something that the data is holding. So there's my database. So there's that database we just created. Okay, see, again, SQLite puts databases in a single file. So that file is, again, our database, which again is more like a folder, and then we're creating tables inside that database. Now, how do we know that we created that table? You can do the command tables, .tables, and that's going to list all the tables that you've created so far. Okay. Now, generally in other types of databases like Postgres, MySQL, Oracle, etc., so forth, there's going to be commands that do all these things. They just might be slightly different. So the SQL will be the same. So the way you write the SQL commands that end in a semicolon will be the same regardless of which database you use, with maybe minor differences. But these database-specific commands, so the not SQL, those will be different from database to database. So in like Postgres, they generally always start with like a forward slash like that. And I don't remember off the top of my head how the MySQL ones look like, but they will differ from environment to environment. Okay, so cool. We created a table. We confirmed that the table exists because when we run the tables command, we can see that the table exists. So let's put some data in there. So create table creates a table. Insert inserts data. So I want to say insert into, and then I'm going to specify which table, my first table. And just so you know, like, you can use the tab key for autocomplete. So I should be able to say like my first table. Oh, nope, actually, my first. Oh, I guess it doesn't work here. It does in Postgres. My first table. Okay, so I'm gonna say, hey, this is the spreadsheet that I want to add the data to, and then I have to describe what data am I giving it. I don't need to give it the ID. So even though our table has an ID and a name field, the ID is serial, which means it's just gonna automatically fill it in with a number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I don't need to give it that. The only thing I do need to provide it is the name. So I'm gonna specify that, hey, I'm just gonna give you a name. Okay, so this is how it always works. Insert into my first table. I'm describing what data I'm going to give it, name, and then I have to give it the actual data, so values, and in a parentheses, I can put in the name, which is generally whenever you're typing in letters, or a string in SQL, you're going to want to use single quotes, not double quotes, not backticks. You're going to want to use single quotes. So I'm going to say the first name is Steve. And then I could actually submit multiple things and insert multiple records. I could say, hey, we're also going to add John. And we're also going to add Alex. Okay, now I can hit enter. Or actually, I have to add a semicolon at the end. So again, you always got to add a semicolon at the end. So again, just say I'm saying insert into this table, being passed the name value, and then here are the actual pieces of data that I want submitted into the database. So I hit enter, and it says, oh, because I spelled my first table wrong. Oh, it thinks there's more letters in it than there actually is for some reason. So let's try that again. Insert into my first table, name, values, and first we'll just do Alex. We'll just do Alex by myself. Just make sure that works. And see, now in SQLite, you know it's successful because there's no feedback. So notice it didn't say anything after the command. Okay, that just means there was no error, so we can assume that things worked out. Other databases will have different responses. So like Postgres will generally repeat the command back to you when it's successful. It'll say like insert. It'll say create. And then that's kind of not how you know it's successful because it told you which command it just did. Here, it'll just give you no feedback. Okay, so you have to assume if I don't get an error, it worked. But I can double check. So let's query the data to see, hey, did Alex actually get added? So what you do is you do select. Select means I want to get data. Now, next you specify which fields you want. Okay, I only care about the name for now. Okay, I only care about name. So just give me all the names, and then get the data from my first table. And then I put a semicolon at the end of the command. Again, every SQL command requires a semicolon. So I'm saying, hey, get me just the names from any record of data that's inside my first table. And see, there's Alex. But what if I wanted the ID too? Well, if I want both, well, that's pretty much everything, right? So a really easy way to say, hey, just give me everything, is just say select star. Star always just really means anything or everything. So let's select star from my first table. And that's going to give you all of it. And I can see here's like the ID, which just looks like a number 1. Well, I don't even see a number there, but we'll go from there. Cool. So let's add a couple more people. Okay, insert into my first table. Again, we're just going to get past at the name. We're going to say values, and we'll add Steve. And Josie. Put the semicolon at the end, so we're adding 2 records. Okay, and see, I got no feedback, so that means it must have been successful. So let's go look for all that data again. Select all from my first table. Okay, now I have Alex, Steve, and Josie. Notice that it's not filling in the number. Okay, I don't see the 1, 2, 3. So that's a hint to me that maybe the SQL and SQLite may be a little bit different than what I'm used to, who I primarily work with Postgres databases. Okay, so then my question is, well, what is the equivalent of this serial type in SQLite? So I can just, do a quick Google. It never hurts to Google something, okay, because you can never remember 100% of the things 100% of the time. So I would say, hey, equivalent to serial in SQLite 3, because the different types of data can change from database to database. So you can see here someone's already having that problem. Okay, so let's see here what the answer was. Yada, yada, yada. We skip to, this is what's called Stack Overflow. Stack Overflow is a great website for looking for answers. It's basically the big hub where anyone who works with code is going to be exchanging information, trying to say, hey, I have this thing that doesn't work. How do I fix it? Okay, and so here, we have the answer. So in this case, if we wanted to do an ID field, we wouldn't do serial. Okay, we would do this. Okay, so integer. So integer means a whole number. Primary key, we already discussed what primary key means. And auto increment means it's going to automatically update. And not null means it can't be empty. Okay, not null means empty. So saying not null means this field is not allowed to be empty. So if I try to pass information and I forget to include the ID, it'll throw me an error. Okay, so now that we've cleared that up, let's go try to make a new table. Okay, which I have right here. And we'll try to create another table. So we'll say create table, my second table. And then we have to give it again the schema. The schema is the description of what the types of fields are. So really what we want to do with ID is say it's an integer field, that it's a primary key field. Again, integer means it's a number. Primary key means it's going to be unique and should be considered the primary identifying record. Okay, so integer, primary key. Auto increment, so meaning it'll automatically keep adding 1. And then not null, meaning it can't be null, can't be empty. So everything has to have an ID. So, and then we'll add the name field again, which is just a varchar, and we'll specify a limit of 30. We'll put a semicolon to end the command, and then we'll hit enter. Okay, and again, I got no feedback, so just to double check the table was created, I'll do dot tables, and I see both my tables there. See, both my tables are now in this database. Pretty cool. Okay, and again, generally the idea here is this. I'm not going to go hand insert all the data into this database. Typically what's going to happen is that this database will be plugged into some other application. So maybe, let's think of a Facebook or a Uber or whatnot. So anytime someone gets a car, data is going into the database. Anytime someone clicks on a like, data is going into the database. And what I need SQL for more so is for me to be able to access this database and query data that I might need. And I might be doing it in here, or I might be doing it through some other interface, like using what's called a Python notebook or whatnot, in order to interact with this database. But I can use, in all those instances, I can use SQL in the code for my application, here in the terminal, in a notebook. SQL is always sort of like an option of how I can interact with that database. It's the way we talk to the database. So we would just program that into our code, and our code would just send all the right queries to add and delete and update all the data. So when I'm using Facebook, it's the code of Facebook that's oftentimes going to be handling a lot of these queries on what's called a transactional front, meaning we interact with we do transactional things. I click on the thing, I make a transfer from one bank account to another. That's going to then do all the proper SQL statements because they're all programmed into that code that is Facebook or Chase or whatever. But again, there will be times where I need to go pull out data specifically, and I may use terminal like this to go in there and say, okay, hey, I know I have these tables. Let me go get this particular data from them. Okay. So I have 2 tables in my database. Let me add some data to the second database. My second table, because you're probably thinking, well, like, for something simple as this, I could just use an Excel spreadsheet and it would be much easier. And in that situation, that may be much easier to sit there and just, if you're going to hand make the data, then yeah, go do it in an Excel spreadsheet, and you could actually turn that Excel spreadsheet to a CSV file and then load it right in here into your database with a few commands. That's a thing you can do. But the idea here is to learn that SQL language and to get hands-on with it to see what is it actually doing. So my second table, actually I want to insert data, so it'd be insert into my second table. Okay. And again, we have to specify what values we're adding. So name, and then the values, what is actually being added. So we're going to add Alex again. We'll add Bob. And we'll add Susie. Okay. And then I'm going to hit enter. See, no, there was no error, so that means it should have worked. So let's try that out. So select all. So I want all the data from my second table. Okay, and there we go. Look, I have the ID of 1, and see it's automatically incrementing the number. 1, 2, 3, Alex, Bob, Susie. So now I can start actually querying the data, which we'll do in the next video, so I'll see you guys there.